Hello everyone, my name is Samyak and I am here to explain about asymptotic notation. Basically, mathematical way to represent time complexity. Here, time complexity means we need total number of time that a particular statement is executed, which is called iteration of frequency. To represent these notations in a proper way, we need some notations such as, let us take an example as A and B are separate algorithm. To compare this particular A algorithm has some time complexity whereas B has some other complexity. We should compare both these and make best out of this, and that is known as asymptotic notation. Basically, there are three types of asymptotic notation. First one is big O notation. We can explain this using graph. Here Fn is the constant and C is constant and Fn is a function. K is there is a condition that K is always greater than or equal to 0. N should be greater than or equal to 0. C is greater than 0. For example, For example, 2n square is a time taken to complete one algorithm. It can be represented at f of n is equal to 2n square plus n. It follows a method known as f of It follows this condition when solving the problem. It can be written as 2n square plus n less than or equal to c dot gn. C is number of constant. It can be simplified as where when compared n and n square will be greater than n, and the equation becomes it can be written as n greater than or equal to 1. It holds good when the n value is greater than 1. N means total number of inputs. Thank you.
So hello everyone, I am Sanmitra. As my friend explained about the asymptotic notation and the first type of notation, today I am going to explain about the second type, that is big omega notation, which is denoted as ohm symbol. Which before going to graphical representation, let us know the definition of the big omega notation. So big omega notation is a minimum time required for the algorithm for execution. It is also called as discrete execution. Discrete execution. As we come to the graphical representation, the y-axis is represented by the total time taken, and this is x-axis represented by the integers. So this one is called as lower bound and this one is called as upper bound. So M1 is the intersection between these two bounds are denoted as M0. So the condition must support. in big omega notation, this condition must satisfy only when f of n, that is upper bound, must be greater than or equal to constant into lower bound, where m is must be greater than the intersection point m naught. Here c is a constant and m naught is a positive integer. The key difference between the big O and big omega is that the big O will satisfy or deals with the condition of our split, whereas the big omega will deals with the condition of the split.
Hello everyone. My name is Shamith. As my friend explained you about the asymptotic notation, I will explain you guys about the big theta, as it is a part of asymptotic notation. As you know, the big O and big omega are the part of asymptotic notation. They show the upper bound and the lower bound. You can also represent as best case or worst case. And here in big theta, it shows both best case and worst case of an algorithm, which means that algorithm will be within the specific range of speed. And if I take in a function f of n is equal to 5n square plus 3n plus 7. Here, if you take the larger value, that is n square, which is dominated. So we will ignore the 3n and 7, and we will also ignore the constant part, which is 5. So we will finally return the big theta function as f of n, theta of n square. Okay. When it comes to the importance of big theta, which gives precise analysis of an algorithm compared to the big O or big omega, and it helps in comparing different algorithms, and it will provide the best algorithm, which is in the efficient one. So, and it also simplifies as it only concentrates about the dominant variable or any which we consider. And as we come to the graph representation, here which this represents the lower bound, and we can write the lower bound as C2 dot G of n is equal to 7 square or 2 square, and upper bound represents the G of n dot G of n is equal to 7 square. And the final big theta graph should be between these upper and lower bounds. So here it is a function f of n is equal to 5n square plus 3n plus 7. So basically the big theta which shows the specific speed of the algorithm when it is executed, which is must be ranged between the